So you minimize that. So again, if this box, if you had left for the evening and tried to turn the lamp back on, essentially you just need to turn off the power up here, the lamp power. Okay? You can leave this box power on.
Okay.
When you come back in the morning, you turn on the lamp, you light it, wait 15, 20 minutes or so, probably. If you're doing reflection intensity, probably wait at least an hour or more, because that's where you really want stuff stable. But once you start up the software, you'll notice that it says hardware not initialized. So that's what I'm saying. If it got closed, you'll have to calibrate anyways. So, because once we initialize, we'll need to do that. So
yeah, I just hit the initialize at the top.
So during the initialization process, it's going to home different motors, home the monochromator, kind of figure out what some stuff is. And then once it's done, so we'll wait for that procedure to be done, it's going to ask you to basically say initialize but not calibrated. When we're doing this. Then I guess this is up to you guys. This will get stored in the log, so if you are having different people log in and you want, it doesn't require a name. It's not like it's password protected or anything, but sometimes people want to know, oh, who screwed it up?
Yeah, I mean, we have logs for these, so putting in our names is probably good.
Yeah, so it basically says initialize, but not calibrated. So it's talking to that box. Now, if that box had not been on, it wouldn't be able to initialize because it needs to be able to. There's an onboard computer in that control.
Hello.
So we'll go ahead and load this way for now. So essentially, the slider you can whether you want it or not. That's just made it for shipping. So yeah, perfect.
Well, it's up large.
You can also use the small one. It's not that big of a deal. It's just mainly you definitely need the small one for the smaller samples. Perfect. Data, calibrate system, and just the standard settings are fine. Do a fine calibration. So it's going to start prepping stuff, the monochromator to a certain wavelength. It's going to should ask you to put the alignment detector in shortly. Oh, I'm so sorry.
Yeah,
oh,
you have to align it, right?
my bad. Sorry.
Yeah.
Pressure. Go ahead. Sorry. Align the sample. I was getting ahead of myself.
So insert alignment detector.
Yeah. It might be close, but yeah, it'd be better to align it first.
Yeah.
So again, the guide pin's going to be towards the top. Perfect. Sorry about that.
You're
align
good.
first. Too much pressure. So these are going to be these two tilt knobs here. Again, you kind of want to like turn it a little bit and then turn a little bit.
It's almost on the.
Yeah. One will be mainly X, one will be mainly Y, so you get a feel for it.
Yeah.
But like I said, it'll do a double step for the update. So if you try to go too fast, you're kind of undoing what you did. So the other one's kind of hidden back there. Yeah.
I remember we used to do this. We got so used to doing it.
You knew which
You could
direction.
just do it like within a few seconds.
Like how you knew how much to turn and on which knob, pretty much. Yeah. You'll get familiar. You're within a few units.
That's good.
So that's good. Oops. Yeah. I know it's tempting to always get it better, but you see it'll move a little bit by itself anyways.
So that's good?
You're good. Yeah, within a few units. So when you say escape now, or it'll continue to the height alignment step. So it's going to go.
So I'll just hit escape.
Yep. I wish it said like continue instead of escape. That's what it is. Now this is where whether I leave this in or out really depends on what I'm going to do for my measurement. So again, for calibration, I take it out. So I take it out. Put it here. For your measurements, it really depends if you want a smaller area or not. For your reflection intensity measurements, we'll probably leave it in to keep a smaller beam, so we can have a better chance of collecting that beam.
Okay.
Versus angle, but we'll give it a go. So now it's going to say maximize the height. So basically, this is going to be the micrometer adjustment. So say okay, and it'll show you your basically intensity screen.
Adjust this.
Yes. So basically, what's happening right now is the tip tilt is correct. So we know that. But if your sample was thicker or thinner, you're going to kind of move the reflection of where the height of that surface is to get the maximum signal into the detector. So you're getting the sample height good part of this correct now. Okay. Good deal?
Yep.
Okay, so also escape and continue. And now that we are aligned, now we can calibrate.
So now we
Go ahead and acquire data, calibrate,
Calibrate.
yes. And the settings are fine. So it'll take a few minutes. So again, this is because we restarted the software, so it looked like, so it shows it's not calibrated. Just to show. We left the lamp on over since it was already warmed up. But it's, again, wanted to show, be familiar with that because that's a pretty regular occurrence. And then when that's done, I figured we might do some reflectives, and then we can look at that data as well. Just depends on what. I also brought a thicker thermal. So this is about 500 nanometer thermal oxide.
Okay.
So I was mentioning is that if you guys are doing thin metals, because it sounds like you might at some point. So optically thin, I can see through 20 nanometers of silver or platinum or whatever. The hard part is if it's thin enough and you have unknowns of N, K, M, and thickness at all wave, basically absorption everywhere, you're kind of underdetermined. So the two main tricks that people use to get around that, and I can forward a paper, is either deposit it on like a Q-silica glass, so something that an easy glass, a well-behaved glass substrate, and then also measure transmission intensity and then fit the ellipsometry data simultaneously with the transmission intensity. Or another trick we use is we deposit on a thick thermal oxide, because that thick thermal is going to set up that interference pattern. It's very well behaved, and if we measure multiple angles, we can basically now have enough information that we call that interference enhancement or artifact minimization. Basically, we can have enough information to figure out the metal as well. So so if you want to, if you're doing that, you can break up that wafer, try it on. If you want to test it, that's the difference. So this is successful. So again, it should be, unless we put the wrong sample on there, or the lamp was off, or something, or something was really weird. While the system's up there, let's do a couple quick things. So I'm gonna just show some manual stuff. So if we go, I'm gonna go. I'll drive for a second.
Yeah, that's fine.
So in general, so right now we've got, we can, I guess let's go ahead and pull off the sample for a sec.
Okay.
And so I just hold it up there, and then I kind of turn off the vacuum, and then kind of make sure it tips into the container so it doesn't just drop. Perfect. And then here, so if you're trying to, if you're trying to kind of troubleshoot things or whatnot, some things that can be helpful. So if we go and I say move, for example, I can move the monochromator. Now currently it's in angstroms. We'll go to nanometers, and so currently it's 1500 nanometer. So it's basically it's in the infrared. I can't see that light, so I can do a couple things. For example, I can move it to white light. So it's going to just go zero off the zero order here for the monochromator. And if we look, so you can kind of see that. So that's kind of your size for your collimated light beam. Okay. So again, at normal incidence, that's going to be here. But when we're at say 70 degrees, like we are now, it's going to spread. So again, your measurement area is going to depend on what angle it is, because as this gets more oblique, it's going to spread. It goes as 1 over the cosine of being. So at 60 degrees, the length's going to be twice the width. 70 degrees is going to be about 3 times the width. 75 is going to be about 4 times the width. Okay. Just FYI. Now, again, if you leave this in while we're here, essentially that's a quick way to kind of get a smaller area. Okay. But you throw away a lot of light, so that's your compromise. Now, when we're trying to get reflection intensity, and I've got an iris over here, I'm trying to get all the beam in there. Again, this was built to be a dedicated spectrophotometer. We would do some things different because we built it to be good at the ellipsometer, and that's a secondary function of the other thing. So, like we would split the beam off and track, fluctuations in the lamp, and we would make sure our beam was always reflected, not bigger than the aperture, stuff like that. So that's at least what you can show there. I mean, you can move it to other colors as well, move it to green, whatever. And just, that's always fun to show.
Right.
Like, look, green light, red light. You can move the monochrome to different wavelengths. I just wanted to kind of show that. If the tilt's always pretty easy. Okay, but if you're like, I can't, like, where the heck is, somebody might have came in here and lined a 1-inch optic. And then you come in here, you didn't know that. And so your reflected light might really be, you put your wafer on there, your reflected light might not even come in the receiver. So if you're having issues with alignment, especially the Z height, you can always kind of put your sample on here and just move the monochrome to the white light and just kind of say, where's the beam?
Right.
Is it coming into the hole here? Currently you can see it over there because it's
Right.
but we've got a sample up here. Does that make sense?
Yes.
You kind of manually look, get it into the aperture, get it into the iris, get it close, and then do your final alignment.
Gotcha.
Right? So that's a trick. Or, especially if you guys are doing a lot of transmission intensity work, again, when we're doing reflectance in a little bit, we won't really be doing this because we're going to be coming off at angle. But when we do, if you do transmission intensity work, like I said, you have to measure a baseline measurement. So basically a no sample measurement in that case. What does air look like at these wavelengths? What's your sample look like at these wavelengths? And figure out what the transmission is. One of the tricks we do for that, because of drift of the lamp and everything else, is we can do what's called interleaving, which goes back and forth. So it only takes like chunks at a time. What's the air look like? What's the sample look like? So we're not measuring the full spectrum in case of something drifts. That takes long. So if we do that, one of the things we can do is we can have your sample up here, your film on glass or whatever it is, and it's going to move this to normal incidence to get the transmission, but it can move it back to 90 degrees and get it out of the way to get the air, as long as the stage is back far enough. So that's why if we're doing transmission or whatever, I might put, I just have this available, put some kind of a spacer here, essentially, to get the stage out of the way. Now that works in transmission, because again, in transmission, it doesn't matter how close their sample is, as long as it's aligned. So obviously, you don't want to align your tip tilt back here. You want to align your tip tilt before you push it back. Okay. But once it's there, essentially, it's kind of a trick. So you can leave your sample mounted. It can move the stage to 90 degrees, and the sample's out of the path. You can figure what the air looks like, and then it can move it to 0 degrees to go through your sample. It's out of the center rotated. Right. It's just when you align your sample, don't have that in. But also, if you're like, why is this not? If you have a spacer here, make sure that this is, when you're doing actual reflection type of measurements, this is all the way back. Okay. You have a sample?
Yeah, it's this one.
So if you want to mount it, but we'll make sure the vacuum is on the small settings or hold where you want it.
Make sure that.
So the fact you can see the beam on it means there's some scatter, right? And this is essentially somewhat of a gradient. So that also, you can position it to make sure your beam is there. We'll putting that in, but before you do, my question would be, what's it look like afterwards? Is it squishing out at all? So because this is a bit of a gradient, right?
Yeah.
So let's go ahead and so we'll put the quad in for two reasons at this point, because we're doing just intensity based. So it's be a little less light, but that's, as long as they have some light, that's less of an issue for that. It should work out good, and we have a better chance of collecting the beam versus angle. So now we still want to align the sample though. Well, here, let me take that back. Let me think about this. Sorry. Since we need to do the baseline, we're going to have to do an air measurement first. Now the air measurement, so we'll have to actually pull that off for this.
Well, we can't throw the spacer in?
Can I do that at 9? Yeah, I can try that. Let's try that. So I guess let's align your sample first since it's already there.
So
again, that works well for transmission. I might be able to trick it for reflection baseline, but we'll have to give it a go. See if that works or not. So if that's, you kind of see where the beam is since it's a scattering sample. So if that's not where you want it on the sample, you can
I
move
think
it
it's
around.
in an okay spot.
Okay.
But
For at least demonstration purposes. Okay.
Because yeah, I mean it's on the grading, so.
oh, so this is just
We still want to get the sample aligned properly.
You still think, yes.
It's got a set monochrome and stuff.
There you go.
That's what I thought white light. So,
gotcha.
So now you go ahead and align the sample. Yeah, we'll try to fool it with the. I just might have to think about it and do a little bit of trial and error.
What? Oh.
leave the alignment detector in since we're going to have it in during the measurement in any case.
And that's where I do this one?
Yep. And here, since the beam is smaller than the aperture, you'll have more of a plateau, more of a flat area. So basically, usually what I do is I go both directions until it starts coming down, and I try to stop, come back in the middle.
Oh,
if that
okay.
makes sense.
Yeah.
So
I see what you mean.
So the
'cause
beam
it-
is smaller than the aperture now, so you're going to have an area where you can go both ways on the spot. So I kind of
Yes.
go a little bit one and I go until it goes, and then just got to get a feel for it. Like here it starts going down, here it starts going down, go back in the middle. If that makes sense.
Yeah. Somewhere in the middle's probably there.
Okay. So I'm gonna experiment for a minute. So I get trial and error. So hit escape. So in general, so if we're gonna do ellipsometry, we're good to go. Take your measurement, do what we need. If we're gonna do reflection intensity, essentially that's gonna be acquired data, R&T data, instead of spectroscopic scan. So spectroscopic scan is your ellipsometry, R&T data is R&T. So here, since we're doing it on sample here, I think what I'll probably end up trying to do, we're going to do we'll try to do, again, we could do all types, which would be P polarized, S polarized, kind of U is by default the polarizer set to 45 degrees. But for now, you're mainly looking for P, just to kind of go quicker. We're going to probably try to just do P. Yeah, probably we're going to try that. The big thing is I'm not sure. Again, it needs a baseline, so it needs to know what air looks like at this point. Again, it might be a little more accurate to do it off the cal wafer. That's kind of the apps note I sent, but that takes a little bit more setup. Usually we're doing that as a function of wavelength, not necessarily as a function of angle.
Right.
So that might take some more trial and error. I'm going to try to just do this as a function of wavelength for now. You might notice that the default unit is probably set back to angstroms. When we restart the software, I'm going to put them back to nanometers. That's what we're in. So essentially, you're going to be doing, what'd you say?
385 or 485. Sorry.
So right now, we're just going to essentially try to do an angle scan. This, I guess before I do that, let's experiment a little bit. So I know that this move angle, I know we can go down to, let's say if we go down to 25, I just want to make sure nothing's in the way. Just want to see how low we can go. So I know.
That's 20?
That's 25.
25.
Will it let you just smack into it?
There's a limit sensor. So
Oh, okay.
basically here, if we go too low, so I think I can go to 15. We're gonna try it.
Yeah.
So you might be able to go 12. I'm not gonna push it
Okay.
because if we hit a limit, we have to reset the goniometers and stuff. It's not that hard, but you got to loosen these and move them around and kind of reset where the scales are. It's in the manual. I can look if we can go further. I'm not going to push it further than that right now.
Yeah.
I just wanted to check where we were. So what I want to see is, and if this doesn't work, we'll just remove the sample, take a baseline, take a measurement. I'm essentially going to just, at the moment, measure the baseline of air, which isn't going to be angular dependent because there's no sample.
Right.
What I don't know is if it's going to let me do that in reflection mode at what I'm going to probably have to call it 90 degrees. So we're just going to check because this might work, this might not work. Again, it's not usually the way I would run it, but I'm going to try baseline only. You said 485?
Yeah.
So try. I'm going to probably say angle 90 and put the shim in. We're going to see if this works. Again, I'm trying to decide whether I need to say 90 or if I need to say, So, sorry, so there's your auto shim. I haven't seen it on this stage there. It's usually over here if they have that. Or it's a little embedded one over here. So that also, sorry about that. So that also is there. Alright, so that's,
So that's helpful.
yeah, it's so you don't have to put that
Yeah,
thing in
you
there.
have to put that shim.
I'm just like,